Okay, so I have a question on the board for you. Sean, how can you measure height in degrees? How? How? How tall are you then?
I grabbed some of my dad's measuring tape and I put it on my foot. Just hold it
Yeah.
up and then
Is that in degrees?
You could do it.
it'll be the sign of whatever. You could do like
Okay, so
You have to use radians.
okay, so the answer would be no. Okay, can you measure distance in degrees? Okay, so you see that degrees is not a fully usable system of measurement for us for trigonometry. It's very useful in some respects, but we need, especially for music, we need some way to measure time. Okay, can you measure time in degrees? I'm sure you could figure some way to do it, but in general, it's not measured in degrees. You don't go 10 degrees. You don't get 20 degrees older. Okay, so we need radians.
one day we will.
Okay. Radians are the basis for the rest of your trig work. They're the basis for calculus. Okay, real numbers are the basis of calculus. It's called real analysis if you're in college, after the calculus 1, 2, 3 are done. Okay, real analysis. So we're going to use real numbers because we're headed to calculus, and also because we need a real number for time measurement in music. Okay. Are we good? Okay. Guess what radians are based off of? Your favorite unit circle. Okay. How many degrees are in one revolution? Okay. And what's the radius of that circle? Okay. So we can calculate the circumference of a circle with what formula? Two pi r, not squared. I would thought you would have known that by now. What's your gaming name? Just come on, give it to me. Oh, probably. What is it? Come on. Okay. I was going to make fun of you on the internet video. Okay. What's the circumference of this circle then? Okay. This is where we get how many radians are in a full revolution. It's the circumference of the unit circle. So 360 degrees is one revolution. 2 pi radians is one revolution. So we can now figure out how to convert between the two. Okay, so the circumference of that circle is 2 pi, right? That's the distance that it takes to go around it. That is the basis for radians. So there are 2 pi radians in one revolution of a circle. 360 degrees is one way around, right? 2 pi radians is one way around. They're the same, equivalent.
Oh,
Okay. The difference being that 360 or angle measures degrees, right? Is an angle measure, whereas 2 pi radians is a distance measure.
oh.
Okay, so you have an angle measurement versus a circumference measurement. Okay, but we can convert between the two. So we're basically translating your degree knowledge into now a measurement. Right, so we relate the two so it's not as confusing for you. So that is true. How many degrees is 1 radian?
Wait, it's half.
Huh? How'd you know that? It does.
What?
If you didn't have a book, how would you know it? If you knew this?
Divide by 3/2.
Yeah.
Oh, so that's like a variable.
So 180 over pi is 1 radian, which just so happens to be about 57.3 degrees. But this gives us a conversion factor. If I'm going from radians to degrees, that's my conversion factor. 57.3 approximately. See, this is an irrational number because pi is an irrational number. We don't need to go into number theory today, I guess. It's a non-ending, non-repeating decimal. How can I calculate how many degrees radians are in a degree? One degree. So 1 degree is 180. Sorry, wrong. Pi over 180 radians. And I believe, Brandon, you have your book. Is that 0.017? So we use these formulas to convert between the two. Get really friendly with fractions. They're our friends. Because radians do not come in decimals. This is just to illustrate for you. Radians will be in fraction form. So if I want to convert (90 degrees) to radians, yeah. How'd you know that? Your book's not going to be in front of you on the test. And it's going to be a short answer question, so I'm going to require you to show your work.
I'll show the chart on the sheet. I'll show the chart. There's my work.
You want to play this game, I can win. Which one of these do I need to convert from degrees to radians? Times 90, right? Times pi over 180. So you do have to simplify that. 90 over 180 is 1/2, right? So 1/2 of pi or pi over 2. Take your pick.
So what does that mean?
Oh, that's terrible. Oh, you know what? It's very awesome. Okay, got it. I'm just remembering how to use this now. So I have a kind of a unit circle up there. Oh, that's how I did it. Okay. Remember, okay, so the circle's not quite centered right, but you get the idea. 90 degrees is, no, it's a circle. It's just not centered.
It's not a circle.
It's an optical illusion.
It is definitely not a circle. Totally not.
Okay, so that's a 90-degree angle, right? But it's also pi over 2 radians. My pen's disappeared for some odd reason, and I'm writing with my fingers, so it's kind of terrible today. So those two measurements, they give us the same location on the unit circle. One of them's a degree measure of the angle, and the other one's the distance measurement of that arc, the arc length. What are the, yeah,
You don't have degrees, like that little circle thing
Yep.
you can put up there. Is there a symbol for radians?
yeah, rad.
That's it?
Radians are rad. Woo! Yeah, no, there's no symbol. You could probably put R and get away with it, but I like rad because radians are rad. Math nerd. Oh, hello.
Our radiation.
That 0.01, right? On the unit circle.
Yeah,
That's this point right here.
you're right.
0, 1. So what is the cosine of pi over 2?
The cosine
0 or 1?
Zero.
of 0.
Yeah, because it's the same as cosine 90, which is 0, and sine of pi over 2 is 1. So it's just a different way to say the same thing. Because we need a real number measurement for time. Time cannot be measured in degrees, so we have to
It
switch.
can be. Circle of life. Circle.
Thank you, Simba. Would you like to sing us the song now? I guess that would be Elton John, but
Rad is the variable representing.
radians is a measurement system like inches. It's just a circular measurement system. Okay. What did we do there? Okay, how about convert? Five pi over 4 to degrees. Yep, it's on the table in your book.
I'll put that chart on my blue sheet right now. And you can know it's time.
Okay, I multiply by this one right here. 180 over pi. First thing you should note, the pi's cancel out. So, because that's the conversion from radians to degrees. Pi over 180 is a conversion from degrees to radians.
Oh, got it.
It's like going from feet to inches. Multiplier divide by 12, right? It's a measurement system. We're just converting between two measurement systems like metric or standard. Okay, so you have to simplify these as much as possible. Okay, so we're almost done. Hold yourselves together. The way I remember to use this, so radians will pretty much always be in some sort of a fraction, or it'll have pi in it. Okay, we need to get rid of pi to get into degrees. So that means we're usually going to divide by pi. So it's 180 over pi. That's how I remember, without looking in my book or anything, which one of those to use. If you go up here, I needed to put a pi into it because I needed to be in radians. So you're multiplying by pi on the top. It puts a pi into it. So degrees 2 radians multiply by pi over 180. Radians to degrees divide by pi multiply by 180. If that helps. Okay, on the unit circle, where's 225?
It's 45 degrees on the third one.
Yeah, quadrant 3, 45 degrees past 180. That's also 5 pi over 4. No, just kind of giving you, here's the numerical way to look at it. There's a graphical way to look at it. So,
Yeah. Line right there.
I like radians because they work. Here's how radians are nice. I have 0, 45 degrees is 1/4 pi, right? 90 is half pi, 3/4 pi,
That's pi.
4/4 or 1 pi, right? And then 5/4 pi, so 1 plus 1/4. 6/4 or 3/2 if you reduce it. 7/4. Those are all the 45 degree multiples. They're fractions. Okay, you can do thirds. Pi over 3 is 60. 2 pi over 3 is 120. 3 pi over 3 is pi, or 180. Okay, so they're all multiples of each other. I find it a touch easier now to work with those. What's the cosine of 5 pi over 4? A reference angle is 45, right? It's a root 2 over 2. It's just positive or negative. Negative root 2 over 2. Yep. And then the sine is also negative root 2 over 2. Okay. So different ways to think about it. Wait. What's, let me give a different color real quick. What is the measurement of that reference angle? 45. Or pi over 4, if you're me. Okay. All pi over 4 multiples, all 45 degree reference angles have these as the coordinates. They're just positive negatives, right? In our case, in quadrant 3, it's a negative x and a negative y. So that's how we got those numbers. Cool? Let me make sure that's all. Oh, I have 10 more things to show you. I'm just kidding. Okay, 6.1. You are going to have homework at the same time that you're working on a project. So it's imperative that you budget your time wisely. I have minimized the homework as much as I can, so you get the practice while still being able to work on your project. The computer cart will be in here every day, so you'll have a choice to make there. Like today, really, like all you really know about the project is choosing your music, you have your chords and your notes, and then start writing your report. The rest of the week, tomorrow I'm going to teach you how to graph the parent function, sine and cosine, and the rest of the week we'll be working on how to graph a sound wave. So by the end of the week, you should be able to have that part of your project done, which is most of it. Okay. Next week, we'll talk about harmony, consonance, and dissonance, and you'll be able to put that in there. So budget your time wisely because you'll have project and homework. But, okay. Anything for the good of the order? Okay. So again, your choice.